Okay, so we have our answer, but we didn't do our significant digits yet. So notice we're not worried about significant digits until the very, very end. So going back to the original question, we were given two numbers. So we have 134.9, that's 4 significant digits. 96.0 is 3, which means we have to round our answer to 3 significant digits. So our 203.92 would become 204 grams. Okay, so I'm going to do one more with you, and then you're going to try out the last one on your own. Okay, so we have calculate the mass of aluminum chloride that can be produced from, so we have aluminum plus chlorine gas, making aluminum chloride. And aluminum chloride is, I believe, a solid. Yes. So we have here, we're going to balance this. So we'll need a 3 and then a 2 and a 2. Okay, so we have the mass of aluminum, which is 20 grams. We have the mass of chlorine, which is 30 grams. And we eventually want to solve for, of course, the mass of aluminum chloride. So again, remember, when you have two different masses, you now know we're doing a limiting reactant problem. So we're going to have to find the moles of aluminum, and then we're going to do the moles of chlorine. Okay, by doing mass over the molar mass, this is going to be just 1 aluminum. We're going to do mass over the molar mass. The molar mass here is 2 times chlorine. So it's going to be 20.0 grams divided by 26.98 grams per mole. So 20 divided by 26.98. So this is 0.7413 moles. And over here, we're going to have 30 grams divided by, so 2 chlorine is 70.90 grams per mole. So 30 divided by that, we get here 0.42313 moles. Okay, so again, if the coefficients were the same, you can just make your decision by looking at which one is smaller here. Okay, but because they're not, we have to prove which one is smaller by dividing each by its coefficients. So here, we're going to take, actually, since I have this number out on my calculator, divided by 3, it's 0.141 moles. And then 0.7413 divided by 2 is 0.371 moles. So now that they're equal, we can see this is smaller, so therefore chlorine is our limiting reactant. Okay, so what that means is moving forward, we no longer care about that aluminum. We're going to use our chlorine to solve for the mass of aluminum chloride. So our next step, we have our mole ratio. So the mole, of course, we want to know aluminum chloride. So the mole value here, remember that we are doing the original mole value, which is this right here, not the one that we use to figure out which one is limiting. And that's for chlorine. So the coefficients are going to be 2 and 3. Ooh, missed it out. Okay, so our x value ends up being 0.42313 times 2 divided by 3. So we get a mole value of 0.2821 moles for aluminum chloride. And then the last step is we're going to solve for the mass of aluminum chloride by doing moles times the molar mass. And the molar mass is going to be 1 aluminum plus 3 chlorine. So aluminum is 26.98 plus 3 times 35.45. So this molar mass is 133.33 grams per mole. So we're going to do 0.2821 moles times 133.33 grams per mole times that. So we get a value here of 37.612 grams. But our value, right, so actually both of these are 3 sig figs. So we're going to have 3 sig figs here. So it should be 37.6 grams of aluminum chloride. Okay, so try this next one out. So calculate the mass of water vapor that is produced when 8.5 grams of methane, so remember you should know what this is, with CH4 and it's a gas, completely combusts with 5.0 grams of oxygen. Okay, so go through the steps, give this a try, let's see how you do. Okay, so we have here methane. So remember the first thing, you always need the balanced chemical equation, right? CO2 and water. So to balance, we need a 2 here, and then we need a 2 here. Okay, so the mass of methane we're given is 8.5 grams, the mass of oxygen 5.0 grams, and we want to solve for the mass of water. So we need the moles of each one. So moles of methane, right, we're going to do mass over the molar mass, which is 1 carbon and 4 hydrogen. So this is going to be 8.5 grams over, so 12.01. So this should be 16.05 grams per mole. 8.5 divided by that, 0.5296 moles. Okay, so then we need moles of, we need moles of oxygen, mass over the molar mass, which is going to be 2 times oxygen, 5.0 grams over 32.00 grams per mole. So 5 divided by 32 is 0.15625 moles. Okay, so here, right, they're not equivalent. So just to prove, to make sure you've determined the correct limiting reactant, this should be divided by 2, which is 0.078 moles. So for sure, between the two, oxygen is my limiting reactant. Okay, so in this case, right, we're going to now use, we don't care about methane anymore. We are going to use oxygen to figure out the amount of water. So we have our mole ratio. We want water over the moles of oxygen, but it has to be the original value, 0.15625 mole. That's a very common mistake that I see, okay? So please try to not do that to yourself. So the ratio is 2 and 2. So we have 2 water, 2 oxygen. So actually our X value is going to be the same because it's times 2 divided by 2. And this is moles of water now. And the last step, we're going to find the mass of water by doing moles times the molar mass. The molar mass is 2 hydrogen and 1 oxygen. 0.15625 moles times 18.02. Okay, so we have 0.15625 times 18.02. So we get here 2.8156 grams. Now for sig figs, we have 2. So over here, our final answer is actually going to be 2.8 grams. Okay, so again, just like with everything else, we are going to add on to this in our next lesson. So it's important that you practice doing limiting reactant problems before we continue on.